Here's number one. It tells us that there's a bullet that's traveling at some velocity that we need to find. This bullet will strike one disk, travel some distance, and then strike a second disk. And then it shows us this diagram of the disks, and it tells us that these disks' displacement was 12 degrees. Well, in order to use the equations we're going to have to use, this has to be in radians, so theta is going to equal to 0.290 radians. It tells us that this distance here is 18 centimeters, which is 0.18 meters. And it tells us that both of these disks are spinning at 6,800 RPM. We also have to put this in radians measurement, which turns out to be 712.09 radians per second. Since we're ultimately solving for v, we'll just say v is unknown, and I'll say the time is unknown. This will be the time between this first disk and the second disk. So to start, I'm going to use the kinematic equations for linear to get a term with velocity. It looks something like this. D is equal to vt plus 1 half at squared. Since there's no acceleration of this bullet, that's going to cross out. So we'll get d is equal to vt, divide t to both sides, and we'll get v is equal to d over t. Now we know this distance, it tells us that it's 0.18 meters, but we don't know this time. So in order to solve for time, we have to use the kinematic equations for rotations, and use this omega and this theta in order to solve. So it'll look like this. It'll be theta is equal to omega t plus 1 half alpha t squared. This is going to cancel out because we're assuming that it's not going to have any angular acceleration. So we'll get theta is equal to omega t. Since we're solving for time, I'll divide omega to both sides. We'll get t is equal to theta over omega. And this is the same time as this is. So I'm just going to turn it over here. And we'll get v is equal to d. And it'll be over theta over omega, which simplifies to d omega over theta. So when you plug in these converted values here, you'll get the right answer.